In question number 61, we have connected a capacitor, a resistor in series with a voltage source epsilon EMF E at t equal to 0. And we need to find the maximum value of the potential difference across the resistor, the maximum value of the current in the circuit, the maximum potential difference across the capacitor, and so on and so forth. So let's take it one by one. I have a video on charging of a capacitor through a resistor. You may like to check it on this channel and go through it because I have explained in detail the whole thing. I will briefly go into those things in this video itself because we need to understand very clearly what happens. Initially, let's say I have not shown it here, but initially there is a switch at t equal to 0. That switch is normally open, and at t equal to 0 we turn the switch to on. When we do that, what happens? A current rushes suddenly into this drawer. There is no charge on this end of this capacitor. So what happens is, you can think of that the current rushes to charge this capacitor with a positive charge here. When there is a positive charge here, there is a negative charge here, and the electrons flow into this direction. You can, the electrons flow into this direction, accumulating there. So in other words, the current also flow into this direction. So you can think of that initially the current flows in this direction, and at that point, right after the switch is closed, you can think of that this particular point is at 0 voltage and this particular point is at epsilon voltage, and therefore the maximum voltage on this resistance for that particular moment of time is epsilon. Now what happens later is a little bit of charge accumulates on this, so there is a slight voltage accumulation across this capacitor. Let us say this is 10 volts, and after a little bit time this one becomes 1 volt. The voltage across the resistor then decreases to 9 volt. Then a little more charge accumulates on this, it becomes 2 volt, this becomes 10 volt. The voltage across the resistor keeps decreasing. But the maximum value of this voltage across the resistor is right after we turn the switch on, and it is equal to epsilon. So this is the whole thing. When the complete thing gets charged, when the capacitor gets fully charged, the voltage on this capacitor will be equal to the voltage on this epsilon, and at that point in time the voltage across R will be 0. That is the answer to the first question. Now when is the maximum current? Right after the switch close the switch, the voltage difference is epsilon. At that particular point of time, the maximum current rushes. After some times, let us say this is 10 volt, this becomes 8 volt, the voltage difference is only reduces to 10 minus 8, 2 volt, and the current reduces. The current keeps on reducing till it becomes 0 after a certain period of time, and then so the max current will be given by epsilon by R. Now the max voltage across the capacitor, and see initially there is no voltage of the capacitor when the switch is open. There is no charge across it, there is no voltage across it. But when we switch the close, the current starts flowing into it, and the capacitor starts getting charged. After a long period of time, the voltage here is, as it charges completely, the current flowing stops only when this voltage is same as this voltage. Because if there is any difference in the voltage, the current will flow. So the capacitor maximum voltage is also epsilon, but it happens at t is equal to infinity. You can say it after a long period of time. Now the maximum energy in the capacitor is when it's charged to full, and that will be half C V square or half C epsilon 0 square. And the maximum energy, maximum rate of the maximum power, you can say, in this resistor, it happens when there is a maximum current into it or the maximum voltage across it. That voltage, that maximum power will be given by V square by R or epsilon square by R, and that will also be the maximum heating on that resistance, and that will be given by epsilon square by R.